All right, let's take a look at some more antiderivative or indefinite integral rules. We're looking at statement number 6, where we're going to learn how to find the antiderivative of x to the negative 1 power, or 1 divided by x. We've discussed this one in class briefly, but I just wanted to have a formal discussion about it. Recall that x to the negative 1 is equivalent to 1 divided by x. So when we're finding the antiderivative of x to the negative 1 of d of x, or 1 divided by x of d of x, that's also equivalent to the integral of d of x over x. And we know that the function that gives us the derivative of 1 divided by x is the natural log of x. And remember, we must take the absolute value of x to remember to follow the domain of the natural log, which is greater than 0. So on A, we will use the constant multiplier rule and bring the constant to the front. I'll rewrite x to the negative 1 as 1 divided by x, just to help see that the indefinite integral of 9x to the negative 1 is 9 times the natural log of x plus c. On example B, we have dx over 5x. So I know the coefficient of 1 over x, or the coefficient of the function, is 1/5 times the integral of 1/5 times the integral of 1 over x d of x. So that's 1/5 times the natural log of the absolute value of x plus c. Rule number 7, we'll learn how to find the antiderivative of e raised to k, a constant power, times x, a variable. So this is an exponential function with base e. Okay, so let's discuss how to construct this antiderivative rule. We know that if we have a function, e to the x power, its derivative is e to the x. But what if we have a function e to the 2x power? Well, we know because e to the 2x is not the parent function, because it's a composite function, then we have to take the derivative using the chain rule. And so then our derivative is 2e to the 2x. So with the antiderivative, our antiderivative will still be the e to the x term. However, we have to divide by the constant power in order to cancel that. For example, if 2e to the 2x is my derivative of e to the 2x, I know that to go backwards, I would have to divide by 2 in order to cancel that. So that's why we have the rule e to the kx divided by k. Remember, k is your constant. So let's take a look at A. Find the antiderivative of e to the x of dx, and our antiderivative is e to the x. So if the derivative of e to the x is itself, that's its antiderivative. But in B, it's a little more complicated because x has a coefficient other than 1. So we'll follow this rule. So the antiderivative is e to the 4x. And now we must divide by 4 because we're working backwards. So instead of multiplying using the chain rule, we will go backwards and divide by that coefficient of x, then plus c. On example C, we have two terms that we must integrate. So in the first term, the constant multiplier rule, minus 8 times the antiderivative of x cubed. And I failed to put d of x dx on c, so please do that for me. All right, so in the first term we would have 2, and we'll follow our rule, antiderivative rule for e to the kx. So e to the 5x divided by 5 minus 8. Now we'll follow the power rule for the antiderivative. So remember, with the power rule, we will add 1. So therefore, this is 8x to the 4th divided by 4. Now we'll go back to make sure we can't reduce anything. And 8 divided by 4 is 2x to the 4th. Remember, there's nothing wrong with taking the derivative of your antiderivative to confirm that you are correct. Okay, I want you to pause the screencast and you try example D on your own. All right, and check and see what you got here. So I pulled the 4 to the front to use the constant multiplier rule, and the antiderivative of e to the 3x is e divided by 3, and then we multiply that by 4. Plus, I pulled 3 to the front for the constant multiplier rule, and the antiderivative of x to the 4th is x to the 5th divided by 5, and then of course plus c because this is an indefinite integral. So for rule 8, I want to point out that there is no chain rule, there is no quotient rule, nor is there a product rule with antiderivatives. So how do we handle finding the antiderivative of these types of functions? Well, if you look at example A, we have 3 terms in the numerator and only 1 in the denominator. So we will have to rewrite this function as a function of 3 individual terms. Then that will allow us to find the derivative of each individual term. And of course it would help to reduce first. 3x squared divided by 2x will reduce to 3 halves x, plus 4x divided by 2x will reduce to 2, and then 1 over 2x will not reduce. And now let's calculate the antiderivative. So the 3 halves will remain my constant. I will add 1, and so that gives me 3x squared divided by 2, or 3/4 x squared is the antiderivative of 3 halves x. Plus, we know that this is 2 is a constant, so it's 2 times x to the 0. We'll add 1 and divide by 1, so plus 2x. Then finally, plus, this is 1/2 times 1 over x, and we know the antiderivative of 1 over x is the natural log of x. Then plus c for our indefinite integral. Finally, on example B, we have a binomial squared. We have no quotient rule, so we will have to expand 2x plus 1. We have no product rule, so we will have to go on and multiply this into individual terms. So 2x times 2x is 4x squared, plus 4x, then plus 1. And now we'll find the antiderivative of each individual term. So for 4x squared, to the exponent we will add 1 and therefore divide by 3. So 4/3 x cubed plus, for 4x, our exponent is 1, so we will add 1 and divide by 1 plus 1 or 2, so 2x squared. And since 1 is a constant, we will, its antiderivative, we multiply by x. Please complete page 137, 34, and 35 through 51. I'm sorry, that should be 34, 35, and 37 through 51 odd. Thank you.